All right, we're going to finish up 8.2. We've already done 2 videos over parts of 8.2, but this is now finding the sum of arithmetic series. And these are finite sums or finite series that have a specific amount of terms, okay? We are not going to be finding infinite arithmetic series. So remember, the arithmetic series is an expression formed by adding the terms of an arithmetic sequence. So you just add all the terms in the sequence together and you get a sum. The sum of a finite arithmetic series equals this equation. Okay? So the sum with a sub n means the sum of that many terms is the number of terms times the average of the first and last term. So it's n times parentheses, a1 is the first term, plus an, which is the very last term in the sequence, and it's all divided by 2. So reviewing sigma notation, it's always like I equals, and we usually have it as I equals 1. Okay, that's like the starting term, n is 1. And the last term is when n is some number. It's going to go to whatever n is, okay? And then our sequence, now this is arithmetic, so it's going to be linear. So you might have like a equation like that, except instead of x, these use n or I, okay? So if we come down and we want to find the sum, and we can use this equation that I circled up here to do that, okay? Now, with finding the sum, there are 3 steps. We need to find the first term, find the last term, then we can find the sum, okay? So I like to list that. My equation for sum here is, I'm just writing it so I can see it on this, so you can see it on this screen. And it's over 2. Okay. So in that equation, we need n, we need a1, and we need an. So if I look at this summation notation right here, this top number is n, so I know n is 20. The first term, which means that's when n is 1, so or in this case I is 1, sorry. 3 times 1 plus 7, that equals 10. And I want the last term, which is what an means, which means I'm plugging in n, which is 20. So 3 times 20 plus 7, and that'll equal 67. Okay, so I found all the pieces that I need. I'm now going to plug them in and find the sum. So the sum of n, which is, in this case, it's 20 terms. So sum of the first 20 terms is going to be n, which is 20, times a1, which is 10, plus an, which is 67, divided by 2. So it's taking the average of the first and last term. It adds them together, divides by 2, finds that average, and then it multiplies that number by the number of terms. So you can plug that in your calculator. If you do and just plug it all in your calculator, make sure this is also in parentheses. Okay, and so you should get 770 is the sum. All right, so for number 2, we need the same pieces. We need n. Here, I'm going to draw a little line to divide that here. N, which is number of terms, which is the 10 on top. We need that first term, so I'm going to plug in 1 for I. I get 9. And I need the last term, so I'm plugging in 10 for I. And that's 90. Okay? We're going to plug it into our equation. The sum of the first 10 terms here is the n, equals n times the first term plus the last term divided by 2. Okay, again, if you're going to plug that all in your calculator at once, make sure that's also in parentheses, and you should get 495. Now, there is a way on the graphing calculators, the Texas Instrument TI-84, sorry, that will let you use this summation notation, but I am not going to cover it. I'm just letting you know that is out there. If you would like to to Google how to do it or want to get on and specifically ask me individually, I will be happy to share that with you so you can check your answers that way. But if you're using the equation right, these will all come out. All right. So number 3, now instead of giving us summation notation, it gives us the first so many terms, and it says it wants the sum of the first 12 terms. So in that case, I know n is 12. I still need the first term, and I still need the last term, okay? Because these are all arithmetic. 8.2 is all arithmetic. So it's all going to need the exact same information. So my first term is right here, is 7. And then I need to find that rule for the nth term. So otherwise I can just keep going until I find the 12 terms. But sometimes you want, like the next problem where you want 34 terms. That's an awful lot to list. So we can quickly find our equation by doing what we did in the previous 8.2 problems, where it looks to me like I'm going to add, whoops, that didn't work, add 5 each time. Okay, so I know my equation for the nth term is going to be a 5n, and I have to add 2 to it to make that first term 7. Okay, so here's the rule. And so to find my A12, I'm going to plug 12 in, because that's how many terms I'm finding, is that 12. And I get 62. Okay. And then we're going to plug it in to the sum equation. So this is the sum of the first 12 terms. It's going to equal n times the first term plus the last term, and all of that is divided by 2. Again, don't forget to put parentheses around that as well if you're putting it all in your calculator at one time. And then your answer comes out to 414. Okay, number 4 wants the first 34 terms, so I need n, which is 34. The first term listed right here is 11.7, and I need the last term. So I've got to find, what am I adding? Because these are all arithmetic, so I know I'm adding something each time. To me, right now, if I take 10.8, subtract 11.7, I get a negative 0.9. So it looks to me like it's subtracting 0.9 each time, because 10.8 minus 0.9 is 9.9, so that is what I'm doing. So for my rule, I get a negative 0.9n, but I need to add something to it to make that first term, so it comes out to be 11.7. So that'll be adding a 12.6. Okay? If I were to check that and I plug 1 in for n, I do get my 11.7. If I plug 2 in for n, I do get 10.8. So, but what we need is our 34th term, our last term. So I need to plug in 34 for n plus 12.6. Type all that in, and I get a negative 18. Okay, so that would be, if I kept going and listing the rest of this sequence, the 34th term would be negative 18. Now we can substitute it into our sum equation. So I want the sum when n is 34. So I add the first term plus the last term, and I divide by 2. Okay. Again, you'd have extra parentheses there. And then you should get negative 107.1. All right, so that covers everything for 8.2.